All right, this is our chapter 1 through 10 review. It is a test, which is why you'll find on Big Ideas, there's no check answer button, right? So we're going to do these together. Number 1, we didn't do any problems like this in our chapter 1. We were too busy solving equations. This is an expression. It says 8x plus 6 minus 7x plus 9. And here's what it wants us to do. It wants us to take our like terms, which are the x's in this case, and it wants us to subtract them. And then we want to do the same thing for our constant terms, which is the positive 6 and the positive 9. So with our x's, someone tell me what 8x minus 7x is. 1x. Yeah, so we can write 1x, or you could just put the letter x, because we know if there's a 1 in front of it, we don't actually have to write that 1. What about 6 minus 9? And don't say 3. It's negative. That's right. 6 minus 9 is the same as 6 plus negative 9. Remember, we can do keep change opposite when we're turning a subtraction problem into an addition problem, even if we don't feel like we need to turn that subtraction problem into an addition problem. There weren't any negatives in that problem, but if you're subtracting away more than what you have, you're getting it a negative answer, and that proves that. Different signs. I know I'm going to go to war. The negative army wins by 3. X minus 3. I like that. Darker color so we can see that better. There we go. All right, number 2. Number 2 is another expression that uses parentheses again, but this time there's something in front of the parentheses. It's a 1/4. What do we do when there's a number in front of a set of parentheses that has 2 or more numbers in it? Or even if it has 1 number in it, what does that mean to do with the 1/4 in front? Multiply. Exactly. We're going to multiply, and we have a particular property that we use when we multiply by that 1/4. You guys know what that is? The distributive property. That's right. It starts with a D. It's the distributive property, and that means we're going to multiply the 1/4 to the 8x, and we're going to multiply the 1/4 to the 16. Now, before I start using fraction rules on this, which I totally could, to take 1/4 of a number is the same as dividing it by what? 4. That's exactly right. In the same way that taking half of a number is the same as dividing by 2, taking 1/4 of a number is the same as dividing by 4. So what's 8x divided by 4? 2x. Exactly. Yeah, so 1/4 of 8 is 2, so 2x for that one. And what's 16 divided by 4? 4. 1/4 of 16 will be 4. So we have 2x plus 4. And then why don't we distribute the 1/4 to the 4x at the end there? Not in parentheses, that's right. So we're going to copy it down. And then, so there's 2 ways that you can simplify an expression. Notice it says simplify. The first way is to get rid of your parentheses by distributing. That gets rid of the parentheses. The second way, that you can simplify, and sometimes you have to do both, like this problem here, is to combine like terms, like we did in the last problem. Those are the 2 ways that you can simplify an expression. And what's the difference between an expression and an equation? It won't have an equal sign. That's right. Yeah, there's no equal sign in an expression. So all we can do is simplify it. We may not get it down to 1 number. What will we get, Landon, when we simplify or combine the 2x with the 4x? Well, are we? They're both positive. We're combining them. You'll get 6x. That's right. So we have 6x and then plus 4. Can we combine the 6 and the 4? No. Why not? Ashlyn, why not? They're not like terms. Yep, so that's my answer. That's as simplified as we can make it. It's much more simplified than what we started with. Number 3. Factor 1/8 out of 1/8 x minus 49/8. Now, factoring something out of an expression is the exact opposite of distributing. When we distribute, We take a number that's in front of the parentheses and we multiply it to the ones inside. When you factor something out, you're not going to multiply, but you're going to divide it. Okay, you're going to divide it out. For example, if I said 2 is a factor of 20, how many times does it go in? It goes in 10 times. You can do that by dividing. So when you factor out a number, it goes in front of the parentheses to show that that's the number we factored out. So when we get our answer is going to look like the way that this problem here started, with a fraction in front of the parentheses because we're factoring out a 1/8. Now we're going to factor out both of these terms by 1/8. How many times does 1/8 go into 1/8? Once. So that'll leave us with 1x, or just x. How many times does 1/8 go into 49/8? 49 times. And there's a minus sign. And that's our answer. When you factor out a 1/8 out of a 1/8, it becomes a 1, or just a 1x here, just an x. And when you factor out a 1/8 out of a 49/8, it becomes 49. So you can double check your answer. You can distribute it back into it, and you should get the same thing you started with.
Do you have to put the parentheses?
You absolutely have to.
And if you don't put them in, you do 1/8x minus 49, is it wrong?
It will be wrong. Yep, you have to put the parentheses around the x and the 49, because if you don't put the parentheses, first of all, if you don't put the 1/8, it doesn't show you factored it out. If you don't put the parentheses, that means you're only timesing the 1/8 to the x, but you're also timesing it to the 49. So we need both of those to be in parentheses. All right, number 4. Am I going too fast?
No.
Okay. Number 4, it costs $25 to enter an amusement park and 25 cents to ride a ride. You have $26. Write an equation. Equations have equal signs. That represents the number R of rides you can ride. So our equation is going to have an R in it somewhere. Now you'll notice that the equation, they've already started it for us. It's going to be set equal to 26. Why is it set equal to 26? That's how much money you have. Exactly. Okay. That's how much money you have. Sure. Thank you. Now, what's the first thing you do when you get to the amusement park? No, before you ride a ride. You have to, before you buy tickets for the ride, you have to get into the amusement park. And how much does that cost? $25. So that, well, is that wrong? Oh, okay.
Grace's binder is here.
Grace's binder is here.
And
Okay.
she needs it.
Okay. So the first thing you're going to do is you're going to pay $25. That's going to eat up a pretty big chunk of your total money. Okay. Plus, what are you going to do after you're inside the park, Taylor? Ride a ride, exactly. And we want to know how many rides we could ride on. And so each ride costs 25 cents. If I was only riding one ride, I'd just say $25 plus a quarter. That's how much money I'm going to spend. But I want to know how many rides I can ride and spend all of my $26. So it's 25 cents per ride. We're going to times that by R. Times 25, it's a quarter for every ride. So a quarter for each of those rides. And that's going to equal 26. Yes, Landon? Now, we already have the equals 26 written in Big Ideas. So on your paper, you need to write the entire thing, just as I've done. But on Big Ideas, they're only going to ask you for that expression right there on the left side of the equal sign. Okay. Now, it doesn't ask us to solve it, but I don't know why we'd write it and not solve it. So on your work paper, I want us to go ahead and do that. So to solve this equation and to get R by itself, what's the first number I would want to move away? The 25 or the 0.25, Nick? The 25. And that makes sense because chronologically, the first thing we did was we bought our entrance into the park. And so immediately after we buy our entrance into the park, how much money are we left with? $1. So 0.25 R equals 1. Now, we would have to divide by 0.25. Now, remember, at this point in time, we weren't using calculators. So let me just ask you this, because this would be a lot easier to think about. 0.25 is a quarter, and how many quarters are there in $1? 4. So that means we would be able to ride 4 rides.
Why would you go with $46? Right, and get $1 to go ride 4 rides?
I don't know, but at least they get to ride 4 rides and not just, can you imagine if they would have only brought $25 and they would have gotten into the park and not been able to do anything in the park? So maybe on, yes. All right, so again, just to clarify, the answer for number 4 on big ideas is just this expression on the left side of our equal sign. We just solved it in our paper. Did everyone get it written down? Did everybody solve it on their paper?
Yeah.
Okay. Number 5 is going to have us solve another equation here. X over 12 plus 1/3 equals negative 5/3. Okay. So I know this has fractions in it. Let's not let that scare us. We have our X term, which includes the 12, which is the denominator. And then we have 2 constant terms, one on the left side of the equal sign and one on the right side of the equal sign. And we're going to do the same thing we did last time. We solved this equation. We took the constant term that was on the left side, which Nick said was the 25, and we moved it over to the other side by subtracting 25. So knowing that our constant term is this one here, I'm going to have to move that over to the other side. And what's the opposite of a positive 1/3? A negative 1/3. That tells me I'm going to move it by subtraction. So it'll no longer be over on this side because those cancel out, opposites cancel out. You're left with X over 12 equals, and then I'm going to go off to the side to do this because I don't really ever subtract or add fractions vertically. We've always done it horizontally. So negative 5/3. Notice how I'm putting the negative sign with the 5. Because if my denominators are the same, I don't do anything with the denominator. So it makes sense to put that negative up top. Minus 1/3. And then I'm going to use keep change opposite because I want to change this subtraction problem into an addition problem. And here's what keep change opposite does. It changes the subtraction to a plus sign and it makes the 1 a negative 1. My denominators are the same. They have to be if I'm going to add or subtract them. So I'm ready to go ahead and look at my numerators here. Negative 5 plus negative 1, do they have same signs or different signs? Same signs. Do they go to war or join forces? Join forces to make negative 6 over 3. Don't forget that they stay negative. I know you might be thinking 2 negatives make a positive, and if you are, you're thinking of multiplication and division rules. Okay. Negative 6/3 is going to reduce. What's negative 6 divided by 3? Not negative 3 over 6, negative 6 over 3. 2 over 1, and what's that the same as? 2. Yeah, so this will just equal negative 2. That's what that's going to reduce to. So now we have X over 12 equals negative 2. So we're not done. Negative 2 is not our answer. It's just what those fractions. That's going to be super nice now. We don't have a fraction anymore. Well, we have the 1 on the left side. But is that really a fraction? I mean, it is, but it's just saying X is being divided by 12. What's the opposite of dividing by 12? Multiplying by 12, yeah. So we don't have to think fraction rules here. We just need to multiply by 12. And what's negative 2 times 12? Negative 24. X equals negative 24. That is the answer because now we have X by itself. Now remember, as you're typing in your answer, they probably already have the X equals written for you. So on your work paper, you assume you have X equals, but when you're typing it in, don't try writing X equals 24, negative 24. Just write negative 24. Number 6, now we're into our fractions, subtracting fractions here, our fractions chapter, which was chapter 2, I believe. It says subtract, write your answer as a fraction in simplest form, and that just means we need to make sure it's reduced. So subtract, no, I don't want to subtract. I want to add. How can I rewrite this so that I'm adding instead of subtracting? Georgia? Keep change opposite. That's exactly right. Keep change opposite. And Georgia, what would that say if I use keep change opposite? That's exactly right. And that looks a lot better than what I was just working with. Ethan, what is 3/8 plus 1/8? That's right. It's 4/8, which reduces to 1/2. That's exactly right. And it does want it in simplest form, so we want to go ahead and write it as 1/2. Number 7. Wow, they're doing you guys some serious favors here. Why have these last two problems with fractions been so easy? Yeah, but that's usually harder than doing multiplying and dividing. They have the same denominator. So all those steps I usually take to get the denominators to line up, I'm not having to do here. Number 7, add, write your answer in simplest form. Do I have to keep change opposite this problem? No, it's already addition. Do I have same signs or different signs? One's a negative. In fact, maybe I should just put the negative up top so we can see it better. One's a negative, one's a positive. They're different. That means I'm going to war. And who wins the war? The -9 or the +9? Neither of them. And what's my answer going to be then? 0 halves, and 0/2 is the same as just 0. Yeah, nobody wins. It's a tie. There's only one number in the world that doesn't take sides, doesn't have a sign, and that number is 0. All right, next up is number 8. It's a multiplying decimal problem. Let's take care of the negatives right now. If I'm multiplying two numbers and they're both negative, what's my answer going to be? What? No, is it going to be positive or negative? It'll be positive. Exactly. Those two negatives are going to pair up. So when I'm going to write my work for this problem, and remember, we're not using calculators yet. I'll let you know when we get there, though. First part of the year, we weren't able to use them. It wasn't until we got to chapter 4 with inequalities. So just hang tight with the calculators. So we're going to have to show our work using, just some side work here. But two negatives does make a positive when I'm multiplying. That's not true when I'm adding or subtracting. We saw that earlier, but it is true when I'm multiplying. So this is going to be a positive answer. Also, when we multiply decimals, we don't actually have to write the decimal point in our work. We could write 66 times 43. The reason I like doing that is because when we see decimals, we tend to want to line them up, which is something you have to do when you're adding or subtracting. But it's something that can throw your answer off if you try to multiply and line the decimals up, because then you end up adding extra zeros and then using extra decimal places that aren't actually there. And so we're just going to treat this like it's 66 times 43 and put our decimal point in at the end. What is 3 times 6? 18, and it's going to be 18 again, but plus one more this time. 19. Thank you. Drop a 0. What about 4 times 6? 24, and the same thing, but plus 2 more this time. 26. So I add those together. Don't forget, we do have to drop the 0 every time we move to the next number, because it's really a 40 we're timesing by, not just a 4. What's 8 plus 0? Good. 9 plus 4? Good. 1 plus 1 plus 6? Good. 2 plus nothing? All right. So 2,838. And then going back to our original problem, how many decimal places were there total? There were 2. So that means I'm going to have 2 decimal places in my answer and make this positive 28.38. Number 9, divide. -7 halves divided by 7/5. Let's take care of the negative. If I'm multiplying two numbers together and one of them is negative, will my answer be positive or negative? It will be negative. I'm just going to go ahead and put a negative right there. I don't need to worry about the negative anymore. So when I go off to the side to write this, how do we divide fractions? Maybe I'm keep change flip. That's exactly right. If you found yourself having issues trying to think back, how do you divide fractions? It's because you don't. You keep change, flip them. And by doing that, what Navion's going to do is he's going to change this into a multiplication problem. We multiply fractions, we don't divide them. So if we ever do have a division problem like this, we're going to flip that second fraction. And what is it called when you flip a fraction upside down? It's called the reciprocal. That's exactly right. Navion, what is this problem going to say? Ignore the negative. What is this problem going to say after you use keep change flip?
It's going to say 7/2 times 5/7.
That's right, 5/7. By doing that, we've actually allowed the sevens to now cancel. And we've, just finished a probability chapter, so I know that we're pretty good at canceling at this point with fractions. The sevens will cancel. You can only cancel when you're multiplying fractions. There's another advantage to wanting to flip it to multiplication. On top, what's 1 times 5? 5. And on bottom, what's 2 times 1? 2. So we end up with -5/2. And when you write that, you can either put the negative with the 5, the negative with the 2, or most people, when they write it, put the negative in the middle. It does say write your answer as a fraction in simplest form. It doesn't say that it needs to be written as a mixed number. Although if it did, it would just put -2.5. But since it says fraction, we're going to leave it as a fraction and not change that. All right, number 10. Write this rational number. Now, a rational number, remember, is a number that is basically a fraction or decimal, including repeating decimals. Write this rational number as a decimal. The first thing I notice about this number is its sign. It's negative. If you put a positive number, it'll say it's wrong. It is negative. Second thing, how do you turn a fraction into a decimal? Top divided by bottom, 11 divided by 5. Not 5 divided by 11. Okay. It's always top divided by bottom. And actually, a lot of times, if it's a proper fraction, this one's not. If it's a proper fraction, it's the smaller number that's going inside the box. Whatever the top number is, that's the one that goes in. How many times does 5 go into 11? How many times, Gavin? 2 times. Okay. And that's going to be what? 5 times 2 is 10. That right there tells you this is an improper fraction, because if it was proper, it wouldn't go in at all. It goes in twice with 1 left over. Okay, now pause for a second. If I had to change this number into a mixed number, I would be done. When you guys did division problems back when you were in probably 3rd or 4th grade, and your number didn't go in perfectly, remember putting the little R for remainder?
Yeah.
Okay, you would say 2 remainder 1. Okay, then you graduated past that and they started making you put the remainder over whatever your divisor is. Then you'd say 2 and then 1/5. Well, that's just a mixed number, 2 1/5. And 2 1/5 would be fine if we wanted our answer as a mixed number, but we want it as a decimal. Does anyone know what 1/5 is as a decimal? Calvin? No. What 1/5 is as a decimal? It's 0.2. So right now we could say, okay, this is just going to be 2.2 or -2.2. If you don't know what it is as a decimal, that's when you just put a decimal point and drop down another 0. And how many times does 5 go into 10? 2. Don't forget to float your decimal point to the top. 2.2. Okay, so we, we're not using remainders anymore. You either write it as a mixed number or you just put a decimal point and you keep going, and this one's going to stop right here at 2.2. Don't forget it's -2.2. The negative doesn't affect any of our work. It just affects that we want to make sure we write this as a negative number still. Taylor? Mm-hmm. Number 11. Which proportion gives you the number X cups of milk in the new recipe? So there's 2 to choose from. I guess we have option A and option B here. Now on your work paper, I want you to write down the correct proportion because we're going to do the extra step of solving it. There's no point just to write it and not cross multiply it. So should it be 1.75 cups of sugar for 1 cup of milk, X cups of sugar for 4.75 cups of, X cups of milk for 4.75 cups of sugar? Should it be this one here? Or should it be 1.75 cups of sugar for 1 cup of milk, 4.75 cups of sugar for X cups of milk? And really, it's just a matter of that second ratio. Is it belong like this, or should we flip it like that? Which one's right, Georgia? It is the bottom one. You're right, because you look here, they don't have since they labeled the proportion, which I'm a big fan of, they don't have the labels matching up. So I know that the X is in the wrong spot. It doesn't take a rocket scientist to figure out that if this is my proportion, then the X should be on the bottom right spot. So on your paper, I want you to write 1.75 over 1 equals X. I'm sorry, Georgia said it was the bottom one. She's right. 4.75 over X. And we're just going to do the extra step of cross multiplying this. Now, you can't use your calculator yet, so I'll cheat and use mine, especially since we weren't supposed to solve this one. But I know you guys know how to do this. Cross multiply the 1.75 and the X. What are you going to get when you times 4.75 times 1? 4.75. Oops, I forgot to write the X. Squeeze that X in there. And then I will cheat because, again, technically we weren't even asked to solve this one, so I'm not going to go out of our way to do it. 1.75 is going to go into 4.75. Oh, I had a slash in mind, the extra slash. That's why it said error. 1.75, it should be. Oh, it goes in a very long decimal. So we're going to round it to 2 decimal places, and we're going to say it goes in 2.7. If it's 714, should I put 2.17 or 2.71 or 2.72? 2.71. Yeah, because the 4 is not enough to bounce it to the next number. So we'll say 2.71, and then X stood for cups of milk. Which one of those ratios is a unit rate? Is it the one on the left or the one on the right? Is it this one or this one? The one on the left side? Why is the ratio on the left side the unit rate? What do all unit rates have in common? Why is it called a unit rate? Davion?
Because that's the unit.
Can you be more specific than that?
That's the unit, that's specific. I don't know.
Kelsey? That's right. The bottom number is 1. Every unit rate has a bottom number of 1. Miles per hour means miles per 1 hour. Right? That's a pretty common unit rate. So anytime you see a 1 on the bottom of your ratio, know that that's a unit rate then. 1.75 cups of sugar for each cup of milk. All right, moving on to number 12. Number 12 says solve y 8 over y equals 4 over 7. Now we can start using our calculators because this is a problem that we would have had in chapter 5. And then I see the next problem here is a chapter 4 problem. So we're good to use our calculators. Navion, explain to me how to solve this one.
Cross multiply the 8 over 7 and 4 in the y, it would be 4y equals 56. And the answer of y is 14.
Now, how did you get 14? I'm not saying you're wrong. I'm just, can you show me that extra step? What did you do once you got the 4y equals 56?
I get 4y divided by 56, so 56 divided by 4.
Perfect. So you divided both sides by 4 to get rid of the 4 that's being multiplied to the y. And what did you say? Y equals what?
14.
Y equals 14. Nice job. Number 13. A number C minus 3.4 is less than 14. Write this word sentence as an inequality. This, as far as writing inequalities goes, this one's pretty easy to write. A number C. So I need to write C. Now, to do this, you'll have to use your keyboard, or you'll have to use the ABC function on your Big Ideas keyboard. But you need to write a lowercase c. And then it says minus 3.4. That's not a trick question. Just subtract 3.4. And then is less than 14. Now, is the less than symbol going to look like this? Or like this on the bottom? The top one is the less than symbol. The less than symbol, remember, kind of makes an L, a side, just to kind of leaned a little bit on its sign. The other one is a greater than sign, and that's going to give me the same number, but then the wrong expression. So to solve an inequality, by the way, that's what they want you to write. They want you to write the entire thing inside that box. And then I'm going to do the extra step of solving it. Pretty easy to solve this one. What's the opposite of a negative 3.4? Yep, and that tells you to add. What's 14 plus 3.4? That's right. Just add 3 more on to 14, 17.4. Okay. So just to be clear, we write the whole thing on our paper, but only going into the box is the inequality C minus 3.4 is less than 14. We'll pick it up on number 14 tomorrow when you guys come in. I will see you guys in here today for success time.